Hi students, today we are learning the topic is Cayley-Hamilton theorem. So in the previous lecture we discussing the topic is eigenvalues and eigenvectors. So to finding eigenvalues and eigenvectors in the previous lecture we learned. Okay, in this class the new topic is Cayley-Hamilton theorem. So what is the statement of Cayley-Hamilton theorem? What is the using of this theorem? Okay na? See that here definition for statement. Every square matrix satisfies its own characteristic equation. So there is any square matrix only. So already finding characteristic equation. Then every square matrix satisfies its own characteristic equation. So this is a statement of Cayley-Hamilton theorem. Okay, see that here. Let A be a square matrix of order n. Its characteristic equation is, so data of A minus lambda is equal to, this is a characteristic equation only. Okay, that is lambda power n plus A1 into lambda power n minus 1 plus A2 into lambda power n minus 2 plus up to so on, An is equal to 0. So by Cayley-Hamilton theorem, the given matrix A satisfies this equation, and satisfies means in the equation replacing lambda by A, constant place lo unit matrix I, that is equal to by Cayley-Hamilton theorem. So A power n plus A1 into A power n minus 1 plus A2 into A power n minus 2 plus up to so on, An into, that is a constant 1 means I, is equal to 0 matrix. So this is a Cayley-Hamilton theorem. So what is the using of Cayley-Hamilton theorem? To find inverse of non-singular matrix by using Cayley-Hamilton theorem. This is using for finding the A inverse only. Okay, now how to finding A inverse? See that. Let A be non-singular matrix of order n. Then A satisfies its own characteristic equation, that is equal to A power n plus A1 into A power n minus 1 plus A2 into A power n minus 2 plus up to so on, Ani is equal to 0, where An is coefficient is not equal to 0. Okay, now free multiplying equation 1 by A inverse. So now multiplying A inverse on both sides only, that is equal to here A power n minus 1 plus A1 into A power n minus 2 plus A2 into A power n minus 3 plus up to so on, An into A power n minus 1 is equal to 0. After multiplication A inverse we getting this equation. Okay, now we want A inverse here. So A inverse is equal, right outside all terms, that is equal to A inverse is equal to minus 1 by An into A power n minus 1 plus A1 into A power n minus 2 plus A2 into A power n minus 3 plus up to so on, An minus 1 into I. This is the finding A inverse only. Substituting all matrices in this one, we getting the A inverse. This is the A inverse for finding the given non-singular matrix by Cayley-Hamilton theorem. So that is equal to, and also we can also find higher powers of a square matrix by Cayley-Hamilton theorem. This is another using. So finding higher power, and that is A square, A cube, A power 4 up to so on, we have to finding higher power of A by using Cayley-Hamilton theorem. So this is a Cayley-Hamilton theorem only. Okay. See the example here. Yeah, first example. Verify the Cayley-Hamilton theorem for the matrix A and hence find A inverse and A power 4. Using this Cayley-Hamilton theorem, we have to finding A inverse and A power 4 and first of all verify the Cayley-Hamilton theorem. So that is a given matrix. So the characteristic equation data of A minus lambda is equal to 0 or lambda cube minus s1 into lambda square plus h2 into lambda minus h3 is equal to 0. So now finding s1, s2, s3 is the same procedure. Okay, already we learned the how to finding s1, s2, s3. S1 is equal to trace of A, that is 2 plus 2 plus 2 is equal to 6. Next S2, minor of sum of the minus of principal diagonal elements of A, that is equal to data of first one. This is okay. Next data of this one, second diagonal elements data. Next to third one, det of third minor, that is equal to simplification 4 minus 1 plus 4 minus 1 plus 4 minus 1 is equal to 9. S3 is the det of A. So det will find out chain 2 into 4 minus 1 plus 1 into minus 2 plus 1. 1 into 1 minus 2 is equal to 6 minus 1 is equal to 4. This is a S3. Substituting S1 S2 in equation 1, that is equal to, from the equation 1, the characteristic equation lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. This is a characteristic equation. So now verifying the given matrix is Cayley-Hamilton theorem gada. And in satisfy this equation, that means that is enough to show that lambda plus lo A replace chain, that is equal to, now to verify Cayley-Hamilton theorem for given matrix A, that is to show that A cube minus 6 A square plus 9A minus 4I constant place lo unit matrix is equal to 0 matrix. This is proof cheyali. Okay na? Now taking LHS. LHS means already A is a given. Next finding A square finding. Next finding A cube finding. Okay. Okay, next continuation. So A square. So A into A find out chain. Multiplication of A into A. This is a first row, first column, second row, second column. That is a first row, third column. Okay. Next second row, first column, second row, second column, second row, third column. Next one, third row, first column, third row, second column, third row, third column. Now to finding, this is the simplification A square. So this is the A square matrix. Okay na? Now finding next to A cube. A cube find out chain. A cube is equal to means A square into A. So already finding A square, this matrix into A matrix. A square into A, and same procedure. Now multiplication 2 matrices. So that is equal same simplification. So this is A cube and okay na? So A cube, A square, AI substituting in the LHS part of the equation. So that is equal to finding A cube minus 6 lambda A square plus 9A minus 4A. This is A cube minus 6 into A square plus 9A minus 4 into I. So simplification, all our simplification here getting, so there is 0 0 0 0 0 0 matrix and 0 matrix. So A cube minus 6A square plus 9A minus 4A is equal to 0 matrix exists. That means the given matrix satisfies Cayley-Hamilton theorem. That is a verified. Okay na? This is a verification of Cayley-Hamilton theorem. So next finding, using Cayley-Hamilton theorem, you have to finding A inverse and A power 4. Okay, see that here. Now to find A inverse and A power 4 by using Cayley-Hamilton theorem. So since we know that this equation by Cayley-Hamilton theorem already proved, okay na? So now pre-multiplying by A inverse on both sides. That is A inverse into A cube minus 6A square plus 9A minus 4A is equal to A inverse 0. So multiply chain A inverse A cube and A square minus 6A plus A inverse into AI into minus 4 A inverse is equal to 0 matrix. So we want A inverse here, remaining right outside. That is equal to 4 into A inverse is equal to A square minus 6A plus 9. Okay, now substituting matrix A square and A and unit matrix, we getting the A inverse matrix. So this is A square matrix minus 6 into A matrix plus 9 into unit matrix. So now simplification this one. So that is equal to, so this is 4 into A inverse. So we required A inverse 4 right outside. So A inverse is equal to 1 by 4 into 3 1 minus 1 1 3 1 minus 1 1 3. So this is the A inverse of the given matrix by using Cayley-Hamilton theorem. Okay, similarly we have to finding A power 4 next. Since we know an equation, this is A cube third degree, we want A power 4 together. So now multiplying a to the equation on both sides, that is equal to free multiplying by a on both sides, that is equal to a into a cube minus 6 into a square plus 9a minus 4a is equal to a into 0, that is equal to a power 4 minus 6a cube plus 9a square minus 4a is equal to 0. So we want a power 4, right outside remainings. A power 4 is equal to 6a cube minus 9a square plus 4a. Substituting a cube, a square, a. Okay, na? That is equal to 6 into a cube matrix minus 9 into a square matrix plus 4 into a matrix. So simplification is, after simplification we getting a power 4 matrix 86 minus 85, 85 minus 85, 86 minus 85, 85 minus 85, 86. This is the required a power 4 matrix of the given matrix by using Cayley-Hamilton theorem. Okay, so next one, find the eigenvalues of the matrix A is equal to 1, 4, 2, 3 and verify the Cayley-Hamilton theorem for this matrix. Find also A inverse and also a power 5 minus 4 into a power 4 minus 7a cube plus 11a square minus a minus 10i as a linear polynomial. And this total polynomial of fifth degree is converted only linear polynomial, that is only power of 1 lo convert చేసుకోవాలి by using Cayley-Hamilton theorem. Okay, now first of all finding the eigenvalues. This is a given matrix. So characteristic equation data of a minus lambda is equal to 0, that is equal to data of 1 minus lambda plus 4 to 3 minus lambda is equal to 0, that is equal to, or lambda square minus s1 lambda plus s2 is equal to 0, or using another formula. S1 is equal to trace of the matrix 3 plus 1 4. Okay, na? S2 data of A is 3 minus 8, that is minus 5. So next finding eigenvalues. This is a characteristic equation. So next finding eigenvalues, write the factors. 8 lambda plus 1 into lambda minus 5 is equal to 0. So lambda is equal minus 1 5. Therefore eigenvalues are lambda is equal minus 1 comma 5. This is the first one, eigenvalues over. So next one, verify Cayley-Hamilton theorem. Okay, na? Satisfy this equation. So now to verify Cayley-Hamilton theorem for given matrix A, that is to show that a square minus 4a minus 5i is equal to 0. So a square finding first. A square is equal to a into a. This is a matrix, this is a matrix. So this is a multiplication both matrices, the result matrix a square. Substituting here, a square minus 4a minus 5 is equal to substituting. This is a square minus 4 into a minus 5 into I. So that is equal simplification. So 0 only. So 0 matrix. So therefore the matrix A satisfies its own characteristic equation. That is a verified Cayley-Hamilton theorem. Okay, so next one, to finding A inverse. Same, since we know that equation a square minus 4a minus 5i is equal to 0. So multiplying A inverse on both sides, that is equal to a minus 4i minus 5 into A inverse is equal to 0. Therefore A inverse is equal to 5 into A inverse is equal to a minus 4i. A substituting A matrix minus 4 into it matrix. So now minus, that is equal to the result matrix 5 into A inverse is equal to minus 3, 4, 2, minus 1. Therefore A inverse is equal right outside 5. 1 by 5 into minus 3, 4, 2, minus 1. This is the required A inverse of the given matrix by using Cayley-Hamilton theorem. So next one, To express a power 5 minus 4 into a power 4 minus 7 into a cube plus 11a square minus a minus 10i as a linear polynomial in A. So by using this simplification, this fifth degree polynomial converting first degree polynomial by using Cayley-Hamilton theorem, that is equal to given polynomial. Yeah, this is can be right. A power 5 minus 4 into a power 4 minus 7a cube ni minus 5a cube minus 2a cube separate చేసినండి. అంటే we have to common here some 3 terms. Okay, that is equal to, so a cube common from 3 terms, a cube into a square minus 4a minus 5i minus this is a 2a cube, so 11a square can be right 8a square plus 3a square, that is 11a square here. Next to 10a minus a can be right 10a minus 11a minus 10i. So a cube into this is equal to 0 కదా, and using the Cayley-Hamilton theorem టోటల్లీ మనం కన్వర్ట్ చేసుకోవాల్సింది ఏ స్క్వేర్ మైనస్ 4a మైనస్ 5కి కన్వర్ట్ చేసుకోవాలి. దట్ ఈస్ ఆటోమేటిక్గా దట్ వాల్యూ ఈజ్ 0 అయిపోతుంది. సో దట్ ఈస్ అ సింప్లిఫికేషన్. ఏ క్యూబ్ ఇంటూ 0 మైనస్ ఇయర్ ఇక్కడ 2a కామన్ అండి ఫ్రమ్ 3 టర్మ్స్, మైనస్ 2a కామన్ ఈజ్ ఏ స్క్వేర్ మైనస్ ఇయర్ మైనస్ 4a ఇక్కడ అండి ఇక్కడ కామన్ ఇచ్చింది, మైనస్ 2a కామన్ ఇస్తే మైనస్ 5i. ఓకేనా, ఇక్కడ 3a స్క్వేర్ సేమ్ ఉంటుంది, నో చేంజ్. మైనస్ 2a క్యూబ్ ప్లస్ 8a స్క్వేర్ ప్లస్ 10a నుంచి కామన్. ఓకే, ప్లస్ ఇక్కడ రిమైనింగ్ 3a స్క్వేర్, సో మైనస్ 11a కెన్ బి రైట్ మైనస్ 12a ప్లస్ a అండి. 10i కెన్ బి రైట్ మైనస్ 15i ప్లస్ 5i, దట్ ఈజ్ ఈక్వల్ టు దిస్ ఇస్ అ 0, this is also minus 2a into this is equal to 0 కదా, సో 0 plus from 3 terms we have to common 3 common, a square minus this is a 4a ఇక్కడ minus 5i ఇక్కడ నుంచి కామన్ 3 కామన్ కదా 15 5i remaining here a plus 5i, that is equal this is a 0. next 3 into this is also 0 కదా, 0 plus a plus 5i 0 a plus 5i. ఇక్కడ total fifth degree polynomial will converted to a plus 5i. this is a linear polynomial in A. so this is a required result. Okay, so next third one, using Cayley-Hamilton theorem finding a power 8 and if a is equal to 1 2 minus 1, given matrix A. next finding characteristic equation, find out. so that is equal to characteristic equation data of 1 minus lambda 2 2 1 minus 1 minus lambda is equal to 0, that is equal to determinant 1 minus lambda into minus 1 minus lambda minus 4 is equal to 0. simplification minus 1 minus lambda plus lambda square minus 4 is equal to 0, that is equal to lambda square minus 5 is equal to 0. this is a characteristic equation. now using the Cayley-Hamilton theorem means already verified, ఇక్కడ using అన్నారు కాబట్టి we not required proof for verify the Cayley-Hamilton theorem, directly using. so by Cayley-Hamilton theorem ఏమవుతుంది, a is satisfies own characteristic equation, that is equal to by Cayley-Hamilton theorem that is a square minus 5i is equal to 0. this is a Cayley-Hamilton theorem result. so we are finding a power 8 కదా using this equation, that is equal to a square 8 outside remaining 5i, we are finding a power 8 కాబట్టి power 4 on both side, so a power 8 is equal to a square power 4 కదా, that is equal to a square is equal to 5i whole power 4, that is equal to 625i. this is the required value, a power 8 is equal to 625i. okay, next one, if a is equal to 2 3 1 2 express a power 4 in powers of a, this is also a power 4 convert into linear polynomial or in powers of a and that is a square, a cube. That is a power 4 can be right. So same by using Cayley-Hamilton theorem. So given matrix, next finding characteristic equation. So this is a characteristic equation, data of 2 minus lambda 3 1, 2 minus lambda is equal to 0. So that is 2 minus lambda into 2 minus lambda minus 3, simplification 4 minus 2 lambda minus 2 lambda plus lambda square minus 3 is equal to 0. That is equal to lambda square minus 4 lambda plus 1 is equal to 0. This is a characteristic equation. So by using Cayley-Hamilton theorem kada, this is satisfy the given matrix A, its characteristic equation, that is equal to manaki a square minus 4a plus I is equal to 0. This is the Cayley-Hamilton theorem. A square minus 4a plus I is equal to 0. Now we have to finding a power 4 kada. So that is equal, a square is equal to here, a square is equal right outside 4a minus I. We want a power 4, that is a power 4 is equal to a square whole square here. But a square is equal to 4a minus I, substituting 4a minus I whole square. Expand 16a square minus 8a plus I. This is also powers of a, or other one linear polynomial convert చేసుకోవాలంటే ఏమవుతుంది, మళ్ళీ a square place లో 4a minus I రీప్లేస్ చేయండి. 16 into a square place లో 4a minus I minus 8a plus I, that is equal to 56a minus 15I, which is also linear polynomial. This is a power 4 in terms of a. Yeah, okay, is it clear? So next one, yeah, this is the Cayley-Hamilton theorem and related problems. For more videos, please do subscribe my channel, like and share it. Thank you.